Symmetry is widely regarded as the ultimate aesthetic of the universe, a sign of order and perfection in the laws of nature. But strictly speaking, symmetry is a death sentence. If the fundamental architecture of reality were truly perfect, you would not be here to contemplate it. In fact, nothing would be here. There would be no stars burning in the dark, no galaxies spiraling in the void, and certainly no atoms to form the complexity of a human brain. There would only be a sterile, featureless ocean of light, expanding forever into silence. The fact that you exist is the single most glaring anomaly in physics, a direct violation of the rules that should have governed the birth of the cosmos. To understand why, we must go back to the first fraction of a second, to the era of the Great Annihilation, where the universe was not a cradle for life, but a slaughterhouse of unimaginable scale. At the moment of the Big Bang, the universe was not filled with matter as we know it, but with pure, searing energy. As this primordial fireball expanded and cooled, that energy began to condense into mass, following the most famous equation in history, E equals mc squared. But nature has a strict accounting system for this transformation. When energy freezes into matter, it cannot simply create an electron or a quark in isolation. It must create a pair. For every particle of regular matter brought into existence, the laws of quantum mechanics demand the simultaneous creation of an antimatter twin, a particle with the exact same mass but an opposite electric charge. This is the symmetry of creation, undeniable and mathematically rigid. But it comes with a catastrophic catch. When a particle meets its antiparticle, they do not bond or orbit one another. They annihilate. They instantly revert back into pure radiation, releasing the energy that created them in a flash of gamma rays. This sets the stage for a cosmic suicide pact. In those first moments, the universe was a boiling cauldron where particles were being created and destroyed in a frenzy of violent equilibrium. Matter and antimatter emerged from the energy bath in equal numbers, collided and vanished back into light. It was a zero-sum game. If the laws of physics were obedient, this cycle should have continued until the universe cooled enough that pair production stopped, and the remaining matter and antimatter would have hunted each other down to the very last pair. The result should have been total erasure. 100% of the mass in the cosmos should have turned back into light, leaving behind a cold, dark, empty void with absolutely no structure. Yet we look around and see a universe overflowing with matter. There are billions of galaxies, each containing billions of stars, vast clouds of gas, and planets made of rock and iron. Antimatter, by contrast, is vanishingly rare, found only in cosmic rays or created fleetingly in our particle accelerators. The universe is overwhelmingly, impossibly lopsided. This creates a paradox that keeps cosmologists awake at night. If the Big Bang produced equal parts matter and antimatter, where did all the antimatter go, and why didn't it take us with it? The existence of a material universe means that somewhere, somehow, the symmetry broke. The laws of physics lied to us. The solution to this paradox is not a triumph of order, but a celebration of error. It appears that the universe exists only because of a glitch, a tiny fundamental crack in the mirror of reality known as cpviolation. For decades, physicists believed that the laws of nature operated identically whether you were made of matter or antimatter, or whether you viewed the universe in a mirror. But experiments with exotic particles like kaons revealed a shocking truth. Nature plays favorites. Under very specific conditions, the weak nuclear force, the force responsible for radioactive decay, treats matter and antimatter slightly differently. It is not a 50-50 split. It is a bias, a subtle preference written into the source code of existence that allowed matter to gain a microscopic foothold over its dark twin. The numbers involved are staggering in their precision and their absurdity. We believed that for every 1 billion particles of antimatter created in the early universe, the cosmos produced 1 billion and 1 particles of matter.
That is the margin of our survival. One single extra quark for every billion pairs. It seems negligible, a rounding error in the grand accounting of the Big Bang, but it was enough to tip the scales of destiny. When the universe cooled and the Great Annihilation began, the billion antimatter particles found their billion matter partners and destroyed them. They wiped each other out in a cataclysm of light that filled the cosmos. But that one extra particle? It had no partner. It had no one to dance the death spiral with. It was left standing alone on the battlefield, a survivor of the greatest purge in history. This changes how we must view everything around us. The sea of radiation that permeates the universe today, the cosmic microwave background, is effectively the smoke left over from that primordial war. It is the fading glow of the billion pairs that died so that the one could live. And that survivor is you. Every proton in the core of the sun, every carbon atom in your DNA, every grain of sand on Earth, all of it is made of that 1 in a billion excess. We are the leftovers. We are the ash that remained after the fire burned itself out. The entire visible universe, with all its grandeur and complexity, is built from the tiny fraction of material that escaped the symmetry trap. But the mystery is not fully solved. While the standard model of particle physics accounts for some cpviolation, it does not account for enough to explain the sheer amount of matter we see. The glitch we have discovered is too small to save us. According to our current calculations, we should still have been mostly annihilated. This implies that there is a larger, undiscovered mechanism at work, hidden physics that drove a wedge between matter and antimatter in the first moments of time. We exist because the universe is fundamentally imperfect, and it is in that imperfection that reality found a way to endure. We are here only because the cosmic equation did not balance to zero.